All right, let's take a look at today's lesson. Today we're going to look at the other four trig derivatives. A couple of lessons ago, we looked at these first two. The derivative of sine is cosine, the derivative of cosine is negative sine. But I wanted to put them all up here together because when I am memorizing, which, yay, we have to memorize, I kind of pair things together in my head. I have a few patterns that I work through that hopefully will help you as well. So let me talk about the patterns that I use. Of course, you can memorize it however you want to, but this is a pattern, some of the patterns. So what I notice is that all the derivatives, of the trig functions that start with the c, they're all have negative derivatives. Okay, so that's the first pattern that I just have in my head. So if I'm taking the derivative of a trig function that starts with a c, I know the derivative is going to be negative. Okay, so that's the first pattern. Then what I do is I pair things together. So I look at like these two. I pair these together. And I memorize them together. So the derivative of sine is cosine, the derivative of cosine is negative sine. They're linked together, if you will. See how they're linked together? Then what I do is I pair the tangent and cotangent graphs together. So these two, because their derivatives are squared. Notice how their derivatives are squared. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So those I put together in my head. That's a tangent and cotangent. And they're reciprocals of each other, so that makes sense, in my brain. It makes sense why I'm pairing those together. The last two that I pair together are these, the secant and cosecant, because their derivatives are products. The derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. So that helps me. Further, I just want to really kind of go a little bit further. So if we recall our sine squared plus cosine squared is 1, recall that identity. I want to show you how much these trig like to, so notice I have sine and cosine in the same trig identity. Okay, yeah, and I paired the sine and cosines together. So if I divide by, sine squared, I get 1 plus cotangent squared equals cosecant squared. Look at this pairing right here. See how in this formula I've got cotangent and cosecant together? Notice how I've got cotangent and cosecant together here, and I have cotangent and cosecant together here. They travel together, if you will. So that really helps me in my brain knowing, okay, well, which ones belong together? Kind of like I don't know, which belongs together. Then also, if I divide that sine squared plus cosine squared by, say, cosine squared, I've got tangent squared plus 1 equals secant squared. And again, see how I've got tangent squared and secant squared paired together, and I have them paired together as derivatives as well. So it's kind of like, I don't know, maybe they're best friends or something. They appear in multiple different ways. Hopefully that will help you kind of solidify in your brain which ones go together. So that's going to be important for us to be able to just, if I ask you what's the derivative of secant, you should automatically be able to say it's secant tangent, secant x tangent x. So that's just kind of something that is going to be important to us. All right, so any questions about the formulas themselves? Because what we're going to do is we're going to practice using the formulas by taking derivatives. And we're also, of course, we've learned product and quotient rules, so those are going to be, come into play as well. So let's take a look at our first example. And we're using theta. Please think of theta like an x. And really, for some students just really get freaked out with different variables. I mean, for whatever reason, they're like, oh my gosh, I can't do that. If that really troubles you, you can certainly rewrite it and call this f of x equals cosecant x plus secant x. you can certainly do that. If you rewrite it like that, I will be fine with that. And that would also be fine on the AP test to rewrite it, changing the independent variable, not the dependent variable. You can't change, okay, so you can't change this name. That's not okay. Changing that name is not okay. Changing the independent variable, that's okay. All right, so, but I'm going to use theta because that's what they asked me to do. All right, so here we go. So f prime of theta equals, so the derivative of cosecant, it's a c, so that's going to, derivative is going to be negative. The derivative of cosecant is negative cosecant cotangent plus, okay, then the derivative of secant is secant tangent. Yes, ma'am.
So you can use the x as well as the,
Oh, no, I went crazy. We shouldn't switch them. I could use all x's if I wanted to, but I should be consistent. Now, if there was a way to add them together, that'd be great. But really, I mean, could I play with trig identities and maybe get a little bit farther than that? Perhaps, but it's really not worth continuing to go on. We would just leave it like this. The only reason that we might want to, let's say we have a multiple choice problem and we don't see that as one of the multiple choice answers, then we might want to do some playing with like reciprocal and quotient, those kind of things. Okay, so we should have in our brain, I'm just going to remind you, cosecant is what, 1 over sine, right? Cotangent is cosine over sine. Secant is 1 over cosine, and tangent is sine over cosine. Okay, again, I'm not going to attempt to change the way they look in any way. I'm going to leave my answer as it is, but I just want us to recognize that it might be, they might have written the answer in a different way. Maybe they wrote it as negative cosine over sine squared plus sine over cosine squared. They might have. You see what I'm saying? So just recognizing the different ways to write trig is going to be important for us. All right, so how are we doing? Is everybody okay? Okay. So let's move to the next page. We've got, let's see, I think we have 5 examples total. Yeah. All right, so let's take a look at this first problem. Let me just say, when I was working through this, you know, I love to do calculus problems, right? I mean, I do. I thought, oh, let's do this one a couple different ways. Let's do it. The first way, which is actually the preferred way, is to get it out of fraction form. And then let's do like a little quotient rule on each one of those. And when I did a little quotient rule on this and a little quotient rule, oh my gosh, it was like, took forever. So if there is a way to rewrite so that you don't have to do quotient rule, that would be advisable. Because we have 2 things that are being subtracted together. Okay? So the very first thing I'm going to do is I'm going to rewrite this actual, you know, subtraction thing. I'm going to rewrite it. If I don't, I have to do quotient rule. So I want to make sure we're clear. If I don't do this, I'm going to have to use quotient rule on this and quotient rule on this separately and then subtract the results. Okay, does that make sense? It's a fraction. Okay, so I want to avoid that, and I will show you why in just a moment. I'm going to avoid that. So I'm going to change 1 over secant. We know from our pre-cal work, our trigonometry work, that 1 over secant is the same thing as cosine, right? 1 over secant is cosine. So I'm going to change this to be cosine t minus, and I've got the 2/3. I'm just going to, you know, this right here, 2/3 is just a fraction. We don't need to be worried about it or concerned with it. It's just 2/3. I'm going to pull it out front. It's a constant. And 1 over cosecant, we know from our work in trig, what is 1 over cosecant? Sine. It is sine. So I'm going to change it. Now, I'm just going to say that's going to make my life much, much easier. So w prime of t equals. So the derivative of cosine, we learned this a few class periods ago. The derivative of cosine is negative sine. Okay, I'm going to copy down the 2/3. This is not a product rule. Now, it is a product. We could use the product rule, but that's going to be much harder. Instead, I'm going to utilize, it's actually on your formula sheet. So the derivative, and I think I put it on the formula quiz today, the derivative of c times f, c being a constant, is the same thing as c times the derivative of f. I mean, that's what I'm doing. I'm pulling the c out. I'm just allowing it to sit there, and I'm going to take the derivative of sine. Okay, so see, I'm pulling it right here. I'm allowing it to sit there, and now I'm going to take the derivative of sine, which is cosine. And that's my answer. Okay. Just so that we are clear as to why that's beneficial for us to rewrite that, I want to show you what would be involved in finding this derivative using quotient rule. Just the first one. I'm not even going to do both of them. I'm just going to do the first one. Okay? So let's just do this as a, this is what would happen kind of thing. All right, so I'm going to do the derivative with respect to t of 1 over secant t. Okay, I'm going to work on that. And I'm going to use quotient rule. Now notice what I got as my answer when I did it I got negative sine t. I just want you to note that. Okay. So if you recall, our quotient rule is fg minus fg, first things first, second things second, over g squared. That's our quotient rule. So this, if you recall, this top is f and the bottom is g. The numerator is f and the denominator is g. So the derivative of 1 is 0. Copy paste the bottom. Minus. Copy paste the top. The derivative of secant is secant tangent all over the bottom, which is secant squared. Okay, so now we need to clean that up. So 0 times secant is 0. So I have negative secant t tangent t over, and I'm going to write this out as secant t times secant t because it's secant squared. Cross that off. I have negative tangent t over secant t. Now, if I simplify this, which I'm going to, I have negative, this sine, tangent is sine over cosine, and secant is 1 over cosine. If I keep change flip, everybody with me so far? Now this is using the quotient rule for doing what I did up there.
Keep everything have to do it this long, or since like the first way worked well, you have to work it out?
Because I'm showing you the benefit of doing it the first way. Because I have students that refuse to do that the first way and they want to do just what they see. They don't want to change the way anything looks. They just want to do what they see and they jump into this. I want to show you that the first way I showed you is the preferable way. Okay? So I'm going to keep change flip. I've got negative sine t over cosine t times, and I'll flip that upside down, cosine t over 1. What do I get? Isn't that what I got at the beginning? Yes. Okay. So I hope that you see the benefit of thinking about doing a derivative before you do the derivative. Okay, does that make sense? We want to think about it first, because since I thought about it and I changed it from a quotient to just a regular, trig function that's not in a quotient, it made my life a lot easier. And that's just the first one with quotient rule. What do you think? I mean, then if I did this one with quotient rule, it would be just that much more. Are we okay and understand why it's a really good idea to rewrite? Okay. All right. So I just wanted to do that little exercise to show it's really a good idea to rewrite if you can. Okay. So let's go to our next one. Are any questions on this one? Are we all good? Okay. So here, unfortunately, there's way too much going on to rewrite. There's a lot going on here. I've got a sine in the numerator. I've got tangent times cosecant in the denominator. Could I try to rewrite? Yes, I could try to rewrite. I'm still going to have a fraction one way or the other, or I'm going to have some crazy sine squared business. So let's just leave it like it is, and let's go through our quotient rule. Now, our template is a quotient rule. Our template. So let's talk about templates. Why am I saying a template? So quotient rule is FG minus FG, first things first, second things second, over G squared. Okay, so what does that mean? That means I'm going to sub into each one of those locations with this information. Now, inside of these locations, I'm going to have to do a product. Okay? And actually, let's see, let's before we jump in, okay, we know that the quotient rule is going to be intense. Okay, let's just see if there's a way to just simplify it just a little bit, even a little bit. So what is tangent? Tangent is sine over cosine, and cosecant is what? 1 over sine. I'm thinking I'm liking that to avoid doing a product rule. What are y'all thinking? Yeah. Wouldn't that be a good idea? Okay, so I really want to avoid the product rule inside of the quotient rule because that's a lot. It's a lot. So let's go ahead and just do one rewrite. I'm going to rewrite here. Again, rewriting is your friend. Rewriting is definitely your friend with trig. Okay, so we're going to turn this, so that's sine y over cosine y times 1 over sine y. I'm just using my quotient, and now you're wondering, oh, that's why she's making us do all that on the formula quiz. Yes, because we use this. All right. Oh, we might be able to just make our lives so much easier by rewriting. So what happens here? Those go away. Okay, so I'm just doing this. So I have sine y. I haven't done a derivative yet. Are we clear? Now this is 1 over cosine. So that's a danger. That's a danger if we just thought it was cosine. How come it's 1 over cosine instead of just cosine? Do we see that? If I multiply straight across like this, right, and like this, I get sine over cosine sine, and I cross the sines out, so that's 1 over cosine.
Can you change that to secant?
Yes, absolutely. That's exactly, because this is the main fraction bar. Okay, we're still working on our rewrite because we found that, goodness gracious, it could save us a lot of work with trig. It sure could. So and I don't really want that fraction there. So let's change this to sine over, let's see, secant. We could, and then we could do product rule. So it's whether you want to do product rule or quotient rule, really, to be honest. What would we rather do? It doesn't matter to me. You want to do product rule instead? Okay, then we'll just change. So instead, we'll keep change flip, right? Sine dividing is the timesing, and then we're going to flip that upside down. And that's what we have. Okay, so now we've gone from this thing, which would have been really complicated. I'm just saying, you thought this was complicated? right? You thought that was complicated. That would be even twice or 3 times as complicated. So we just did ourselves a big favor by rewriting. Rewriting is good. All right, so let's do our product rule then. So we're going to write that down. So FG plus FG, first things first, second things second. All right, so here we go. So this one is F and this one is G. Okay, so now we're finally getting to our derivative. But with all that, it's still beneficial that we did that. I hope we can see that we don't just blindly go into the problem. All right, so the derivative of sine is cosine. Okay, and then we copy paste G, which is cosine, plus, then we copy paste F, which is sine, and the derivative of cosine is, what's the derivative of cosine? Negative sine, beautiful. Okay, so let's clean that up. So we've got cosine squared minus sine squared, and that's our derivative. Does that ring bells with anybody? Yes, cosine 2 theta, or 2y. Yeah, it's cosine 2y. So we could simplify. So I'm okay if you leave it like this. I'm okay. But I'm telling you that probably our answer, if it were multiple choice, this would probably be the double. This is a double angle for cosine, right? So this is this. Those are equivalent. That was fun in a trig way. Oh, if you're missing trig, this is your day. This is the best day ever, right? This is trig day. I love this day. I love trig. Okay, that's all right. I'll calm down. Are we okay with this one?
You would have gone the same thing.
You would have. You would have. It would have just taken a lot of simplification to get there. A lot of work. All right. So this one, cotangent times cotangent, we don't really have any choices here. We're going to have to do product rule. We can't really rewrite those to make it any better. I mean, you could write cotangent as 1 over tangent, but then we'd have, quotient rule. You could write it as cosine over sine, but then we'd have quotient rule. So there's really nothing we can do to help us. So we're going to have to do product rule. So here we go. FG plus FG, first things first, second things second. Okay, here we go. So G prime equals. So the derivative of cotangent is negative cosecant squared, copy paste cotangent, plus, pause here for a second. So this is F and this is G. So then I copy F, which is cotangent, and I take the derivative of cotangent, which we said is negative cosecant squared. Now I have negative. So I'm going to rewrite this so it's clear so you can see what's happening. Maybe some of you already can see how I can combine these together. Maybe you can. I don't know. But I'm just going to rewrite it so it's more clear. I have negative cosecant squared cotangent minus cosecant squared cotangent. So if I have negative 1 cosecant squared cotangent minus 1 cosecant squared cotangent, how many cosecant squared cotangents do I have? Negative 2. So I have negative 2 cosecant squared cotangent. And we should just leave well enough alone. All right. How's that? Okay. We have one more example. Does anyone need a little bit more time? Okay. Let's go to this. All right. I kind of want to see if there's a way I can rewrite h of x to make my life simpler. That looks kind of intense. It really does, doesn't it to y'all? I want to try my rewriting. Now, I might have to just give up and do the derivative of what I have here, but I really want to try. I want to try to make my life a little easier. So let's see what's going on. So I've got, I'm just not doing derivatives right now. I'm just trying to make this easier. So I've got cosine, and I know tangent is sine over cosine. Okay, so I'm thinking there's going to be something nice happening there. Don't y'all agree? That's going to be nice. These, when a fraction is set up like this down here, this is called a monomial. Remember from previous years, that's a monomial. If I have a monomial on the bottom, then I can split this fraction into two pieces, and I think that would help me. So I'm going to actually, split it like this and like this. I'm going to split. And I'm just going to write it like that. I'm going to split it as sine x over sine x plus tangent x over sine x. Bless you. Okay, I'm just in my rewriting mode. I haven't done anything yet. Okay. Is everybody okay so far? Okay, so I think we're going to be able to do some good stuff here. It is going to be. Yeah, we're going to get right there. Okay, so I'm going to, I hope we can see that those cosines would cancel. So I'm just I'm just rewriting. So this first term actually is simply sine. And that's going to be way easier to take the derivative of than cosine times tangent. I hope we see that. Way easier. Okay, plus sine over sine. What can I reduce sine over sine to? 1. Okay, that's even easier to take the derivative of. Yay. Now this last one, maybe we can make some good with it. I don't know. I'm going to rewrite. So that's tangent is sine over cosine over sine over 1. If I keep change flip, is that going to make my life easier? It sure is. So I'm going to do that. My goodness, why wouldn't I do that? Why wouldn't I rewrite to make my life easier? So sine of x plus 1 plus, so let's see, that was sine x over cosine x times, and I'm change the division to multiplication, flip the bottom. Okay, wonderful, wonderful. We're making some good progress here, ladies. So I've got those gone away. Yay. So still in the rewrite phase. So I've got sine x plus 1 over cosine x. I do not want to do the quotient rule here. What's my other option? Yes, I want to turn that into secant. So finally, now that was a lot of rewriting, but I promise you, the work that we spent, the time that we spent rewriting is well worth the time that it would have taken us to do that derivative. Okay, so good. This is going to be much easier. So now h prime of x is, so the derivative of sine is cosine. Do we remember the derivative of 1? 0. The derivative of secant is secant tangent. Wonderful. And then they wanted us to find a value. They wanted us to find the derivative at pi over 3. Okay, so let's do that. So they want us to find h prime of pi over 3, and that would be cosine of pi over 3 plus secant of pi over 3 times tangent of pi over 3. And you're like, oh, that's why we have to do unit circle values all the time. Yes, this is why. So I'm going to, my unit circle, we've got pi over 3 is like right here. Let's think about that coordinate point. So let's see, the x is shorter, so that's 1/2 root 3 over 2. So that's my x and that's my y. So we know that cosine is the x, so that's going to be 1/2. Secant is 1 over cosine, right? Secant is 1 over cosine, so 1 over 1/2 is what? 2 times tangent of pi over 3. So tangent is sine over cosine, so root 3 over 2 over 1/2. So keep, change, flip. What do I get with that? Like, what, root 3? Okay, is that looking okay to us? And that is what this is. H prime of pi over 3 is 1/2 plus 2 root 3. Okay.